Okay. Today I will show you several homework problems for chapter 1. Question 8 asks you that each of these describe a physical change or chemical change. A helium gas inside a balloon tends to leak out after few hours. So clearly this is a physical change because uh, helium gas inside the balloon leak out, out, leak out, still helium gas, just leak out of the balloon, but still helium gas, no change. So very clear, this is physical change. B, a flashlight beam slowly gets dimmer and finally goes out. Flashlight beam slowly gets dimmer and finally goes out. This flashlight beam at first is very bright and after a long time becomes dimmer, then finally goes out because the battery inside the flashlight dead. The battery supply electricity. Then electricity comes from chemical reaction inside the battery. If the chemical reaction complete, then no electricity can be supplied to flashlight. So goes out. So clearly this is the chemical change. C. Freezing orange juice. Frozen orange juice is reconstituted by adding water to it. So you add the water to a frozen orange juice, just dilute the orange juice, becomes lighter sweet. Okay. So no chemical reaction will happen. If there is a chemical reaction happens, then you cannot drink it. This is a physical change. D. The growth of plants depends on sun's energy in a process called photosynthesis. So this process is a chemical change. So the photosynthesis is a plant that uses sunlight to synthesize nutrition. So the actual reaction is carbon dioxide and water under sun's light synthesize glucose. And release oxygen. So 6 carbon dioxide, 6 water, then produce 6 oxygen molecular. So any plant's growth depends on the sun's light because of this photosynthesis chemical reaction. So clearly this is a chemical change. E. A spoonful table salt dissolved in a bowl of soup. So it dissolves salt in bowl of soap or in a cup of water. This is no chemical reaction, just a physical change. Salt dissolved. Or you put a teaspoon of sugar in a cup of water, still physical change. No chemical reaction. It's the same. Okay, next one. Question number 20. Ask you convert the following temperature to Kelvin. So I just show you one from Celsius to Kelvin, and I show you another from Kelvin back to Celsius. (113 Celsius degree to Kelvin), right? Celsius, each degree in Celsius, same as each degree in Kelvin, but their starting point is different. So Celsius convert to Kelvin you need plus 273.15. Or if you use 273, it's fine for me. Then this will be 386.15 K. This is A1. Let's show you B1 is from carbon back to series. 77 K. What is series degree? So from series to carbon is plus 273.15. Then from carbon back to series will be minus 273.15. Then this will be negative 196.85 K. 85 Celsius degree, not K. This is from Kelvin to Celsius. Not 0.85, 0.15, sorry. This 0.15, yeah, minus 73, then negative 200, then minus 4, yeah. So either convert the Celsius to Kelvin or convert the Kelvin back to Celsius. So Celsius to Kelvin is plus 273.15. Kelvin back to Celsius is minus 273.15. Then next is number 32. Question number 32 is a dimensional analysis. 32, let's see, 32B. Convert cubic centimeter to cubic meter. 68.3 cubic centimeter to cubic meter. So first of all, we need to know the conversion factor. Standing 10 to the negative 2, right? That means 1 centimeter equals to 10 to the negative 2 meter. So, but I need to be careful here. It's a cubic centimeter, not centimeter. The cubic centimeter means 1 centimeter cubic. That means 1 centimeter times 1 centimeter times 1 centimeter, which is 10 to the negative 2 meter cubic. And it's 10 to the negative 6 is the power cubic meter. Okay. So your calculation will be 68.3 cubic centimeter. And 1 cubic centimeter is 10 to the negative 6 to the power cubic meter. So in this way, cubic centimeter cancelled, leftover cubic meter is 68.3 times 10 to the negative 6 to the power cubic meter. And 68.3 is greater than 10, so we can move 1 decimal place. And this 1 decimal place is 10 to the 1. And here I have 10 to the 6, negative 6. So 1 combined with negative 6 is 10 to the negative 5. So your final answer is 6.83 times 10 to the negative 5th power cubic meter. And give you one more dimensional analysis, but this not come from your textbook. Actually, I can pick one from textbook. It's 31. Convert milligram to kilogram. Okay, let's say 31. B. 25 milligram to kilograms. 25.4 milligram to kilogram. Okay, so milligram to kilogram, we have conversion factor. Milli means 10 to the negative 3, right? Kilo, 10 to the positive 3. So this means 1 milligram equal to 10 to the negative 3 power gram, or 1 kilogram equal to 10 to the 3 power gram. These two conversion factor. So now 25.4 milligram or 1 milligram equal to 10 to the negative 3 gram. The milligram must be in bottom, so cancel this milligram. So leftover gram. First we convert to gram. Then we need to convert to kilogram. Now this time kilogram in top because we want this kilogram. Then gram in bottom. So 1 kilogram 10 to the positive 3 power gram. So now gram cancelled, leftover kilogram. This means 25.4 times 10 to the negative 3 divided by 10 to the positive 3. So this means 25.4 times 10 to the negative 3 divided by 10 to the positive 3. That means times 10 to the negative 3. Division is minus if multiplication is plus. So this total will be 25.4 times 10 to the negative 6, or 25.4 is greater than 10. So we can move 1 decimal place. Then you have 10 to the 1 together with negative 6. So total will be negative 5. So your final answer will be 2.54 times 10 to the negative 5th power. So this is your final answer. 2.54 times 10 to the negative 5th power kilogram. Okay, that's it. Wish everybody can practice the other homework, and we will have a quiz in next class.